All right. Back to integration a little bit here. Yeah, a lot about what we do in this course is figure out different ways we can integrate things, because integration, there's just a lot of complications that you can have when you run into an integration problem. And so here's going to be another tool, and that is going to be what we call integration by parts. Let's first of all just look at one where we have a little bit of difficulty figuring out with so far what we've done. Okay, so we know that unfortunately if you have a product, you can't do antiderivative of the first times the antiderivative of the second to get that integral. It just doesn't work that way. Plus, minus, okay, those you can do individually, separately, but not times or divide. And so the next best thing, I guess, if you will, other than that, is U substitution. But U substitution won't work on this either because, well, we just wouldn't be able to get rid of the x. We wouldn't have anything, you know, what are you going to call U sine of x? Then du is cosine of x. Well, there's not even a cosine of x that would be able to counteract that, if you will. Yeah, it's just U substitution doesn't work every time either, unfortunately. And so another tool we'll have at our disposal is this so-called integration by parts. And here, it won't always work either, but it will work on this one. And so here's kind of the rule for it. It's a little different. It's different than U substitution. Here's the statement of it. If you've got the integral of u dv, I'll explain what that means here in a second. Well, basically what it means is you pick part of it to be u, and then the rest of it is dv. And it doesn't have to necessarily be just dx. I mean, dv could have an expression of x with it. But anyway, if you get those parts assigned, then here's what it works out to be. It's u times v minus the integral of v du. And that's probably more what you remember. U times v minus the integral of v du. Probably doesn't mean a whole lot to you right now, but here's what we can do with that. All right, so let's take our example here, the one we start with, and apply this integration by parts. Okay, so when you do integration by parts, like I said, you're going to call part of it u and part of it dv, and it may not be obvious which part's u and which part's dv. It may not be exactly in the order that it comes. Here, in this particular case, it is kind of in the order that we want it. We're going to let u be x, and then so that means the rest of it is dv. Okay, and so that's what we're going to put right here. U equals x, and then dv equals sine of x dx. All right, now same drill. It's like substitution here. We want the du, because du is a part of this formula here. So du is the same thing. It's the derivative of that, which is 1 times dx. Now the thing about this one is you don't have to solve for dx here because you're plugging in du. So that's what we're going to plug in for du. And this, it just turns out to be dx. It's 1 dx is dx. Now, the other thing though, this is dv. What do I need in the formula? I don't need dv, I need v. So to get to v, what I'm going to do is integrate both sides of that equation. Because the integral of dv is v. And then the integral of sine x dx, well, that's hopefully an integral you can do the antiderivative of. Sine of x, the antiderivative, negative cosine of x. Now, notice I didn't put the plus c. We'll put the plus c at the very end because we still will have an integral to do when we plug it in. Okay. So once you've got those four things, two things really, I guess it's four, but then we're just going to plug it in to these, to this formula. We're going to set up u times v plus the integral of v du. What does that amount to here? Well, u is x, v is minus cosine of x. Pretty easy. Nothing to do there, just kind of combine those two together. Then we have another integral now.
Isn't it minus?
Huh?
Is it minus the integral of v du?
Yes, thank you. Minus. I had it right here. I was just checking, making sure. All right. Yes, minus the integral of v du. Okay, so it's minus what? V is minus cosine of x. Du, well, good news here, du is dx. It won't always be that nice. But this makes sense. Okay, so what have we done? We've gotten it to this, which now, you know, that's just what it is, minus x cosine of x. We can pull out the minus here, so that is going to be a plus. That's what I was just jumping ahead there. I knew that was going to be a plus there. No, it's plus cosine of x. Yeah, this is now a doable integral, isn't it? That's just an antiderivative of cosine of x, which is sine of x. The antiderivative of cosine of x is positive sine of x. Is that right? Now this is where we, since it's an indefinite integral, we put in the plus c because we started with an indefinite. Ah? Question? Okay. All right, now, we didn't prove that this, does that really work? Well, the proof would be to check this. How can we check it? Yeah, take the derivative. If we take the derivative, we should wind up with what we started with, right? All right, so that'd be, derivative of that would be minus 1 times cosine of x plus minus x times the derivative of cosine of x would be minus sine of x plus the derivative of cosine of x, I did the product rule there, for that, plus the derivative of that would be cosine of x, derivative of that is 0. Cosines of x, gone. Minus times minus, you got x sine of x. That's where we start. So the derivative of this is x sine of x. So the antiderivative of this is this, you see. Okay. So it works. Works out well. You don't have to check it every time, just showing you that it does work. Okay? All right, how about the integral of x cubed ln of x dx? All right, this is a good example of, yeah, it may not be set up, you know, you may not say, well, this is u and this is dv. Now, the reason here, okay, so how do you know? Well, I mean, you just plug it. If you want to try that, try that. But, yeah, what you're wanting though is you want to be able to do this derivative. Now, you know, you can do the derivative of anything, so that's not. But what else do you want? You want to be able to do the integral of this v du stuff. And if I do this, so if v equals ln of x dx, or dv, if I do the integral, all All right, I don't know anything about that. Okay, well, we can figure it out, but it's not as easy as some others. So sometimes I can help you decide, what integral is that going to make me be doing? Now here, u equals ln of x, because that's going to be a much easier derivative than is an integral, right? And then dv is the rest of the stuff, x cubed dx. And simply because it just sets up an easier integral that way. Okay? So here, if we do that, du equals derivative of ln of x is 1 over x and then times dx. Integrate both sides here, so you got v, integral of that's just power rule 1/4 x to the 4th. We'll do plus c later on. Yeah. Okay, so doing that seems to be pretty good. So let's go with that. All right, so this would be then u times v minus the integral of v du. What is that going to be here? Well, u times v would be ln of x times 1/4 x to the 4th minus the integral of v 1/4 x to the 4th times du. So it's 1 over x dx. That's going to work out, isn't it? Because this is, however you want to write that, let's write it. Let's write it the other way. The ln of x last. But this is going to work out because x to the 4th, that's just x to the 4th over x, if you will. And that just becomes x cubed. So I've got 1/4 x cubed, or bring out the 1/4. That's just a power rule. Power. So you got 1/4, but it's going to be another 1/4 x to the 4th, isn't it? Let's see. 1/4 x to the 4th, ln of x minus 1/16 x to the 4th plus. Oh. Is that okay?
I don't know, I think we should check it, just to make sure.
Check it? I'll leave you to check it. All right. Well, remember we were talking just now about what's the integral of ln of x? Well, that's the next one I'm going to do.
Yeah.
I forgot that. All right. Well, it turns out, to do the integral of ln of x, you have to do parts. Now, it doesn't look like there's enough pieces to do parts with this. Because a while ago, we had two things and then dx. Here we just have one thing and then dx. Well, that's okay. Let's still let u equals ln of x. And then dv, so what would dv be? It's not a hard one. Yeah. So actually, this is a pretty easy one by parts. So du would be 1 over x dx. Integrate, you'll have v equals x, won't you? So u times v, the ln of x times x, u times, minus the integral of v du. So you got x ln of x minus the integral of dx. Well, that's easy. The x is canceled, so that's an easy. Just x, isn't it? Let's see. So, it was that bad. Now the good news too, does anybody have that sheet, formula sheet that I gave you? Isn't this one listed? Is this one listed? Integration rules? That one's not on there?
I'm gonna add it.
It is on that?
No, it's not.
It's not, okay. I thought it was. Okay. I believe it is one of the ones listed in the back of the book. But anyway, the way you do it is by parts. And, by the way, too, I mean, we could do these, if it had limits of integration, of course, you wouldn't put the plus C on there, it wouldn't have to. But yeah, if we said do this from 1 to 2, at this point, you're just plugging the 1 and 2, so it's same old. To get that value out. But let me show you one more. Okay. X squared times e to the 2x, that dx. Whoops. Doesn't look too daunting. But let's see what happens here. What do you think? U equals x squared, and try one way. If it doesn't work that way, try it the other way, or try it another way. But yeah, I believe you're right. Well, du then would be 2x dx, and then integrate these, so you have v equals, now, e to the 2x, that's not a simple antiderivative, but it's just a u substitution, isn't it? U equals 2x, du equals 2 dx, so du over 2. So that'd be the integral of e to the u times du over 2. Yeah, it's just going to be 1/2 e to the u. Now, I am using some liberty here a little bit. It's not the same u as over here, but you know what I mean. Call it u1 or u2. I think it's easy. But anyway, yeah, it's just e to the u, so it's 1/2 e to the u, and u is 2x, so it's just 1/2. It doesn't turn out to be too bad. It's just 1/2 e to the 2x. I like to call those kind of simple substitution ones. You just wind up with a factor. Extra factor there, what normally it is. Is that okay with me? All right. Okay, so this equals then u times v, x squared times v, 1/2 e to the 2x, minus the integral of v, 1/2 e to the 2x, times du, 2x dx. You're really going to love this. Okay. Now, all right. Well, it didn't quite maybe turn out like we had hoped. This part, 1/2 x squared e to the 2x. That's not what I'm talking about. It's this part. Of course, the 2's cancel. It's that integral there that we came up with that's not exactly like we wanted it. Because, why? We still have times in my integral, right? However, it's a better integral than we started with. So we've accomplished something, right? It was x squared e to the 2x. Now it's just x times e to the 2x. So we've decreased the power by 1. So guess what?
Gonna do it again?
Try one more time. Yeah. So we got to do int by parts on this one. So you can apply integration by parts multiple times. I'm sure that's lovely news for you to hear, right? Integration by parts. So just like before, we're going to let u be the x, and then dv is the e to the 2x dx. Oh, that's good because now, well, du over here would just be dx. And then this integral, notice it's the exact same integral as I had. So it's another u substitution, but I already know, cut to the chase here, it's 1/2 e to the 2x. So that one just comes down. And then the other thing is this is minus then this integration by parts, isn't it? Minus the u times v minus integral of u. So I guess it's u3, isn't it? And v2. Anyway. It's not too hard to keep straight, I don't think so. But yeah, it's minus all of this, so it'd actually be minus uv plus vu. What do we got? U times v, so it'd be x times, so it'd be the 1/2 x e to the 2x again. Minus the integral of v, 1/2 e to the 2x, but the good news here is du is just dx. So the integral now we have to do, can we do that one? Yeah, that's just a simple substitution one. Again, this minus, will make that a minus, that a plus. Like I said, this is this is just u substitution, u equals 2x. du equals 2 dx, so du over 2 is my dx, so you know what it's going to be probably. 1/2 x squared e to the 2x, 1/2 x e to the 2x minus plus, so we're going to have 1/2 times, that would be e to the u, and then du over 2. So it's just going to amount, I'm going to have another half on it. So we get 4. So it's 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the u, but u is 2x, so it's 1/4 e to the 2x. Let's see.